All right, I'm going to try to keep this one short because I know you guys are still trying to finish up yesterday's assignment. Today is 11/7, and we're going to take a look at solving systems with row operations. All right, so this one's going to go ahead. We're going to start by taking a look at a problem. Just kind of set it up here. We're going to dive right in. So here I've got a system of equations that says 3x plus 2y equals 8. And my second equation will be 5x plus 3y equals 14. Okay, so there's my system, and I want to figure out where these two lines intersect. What I'm going to do is I'm going to set up what's called an augmented matrix, and we saw this when we were finding inverses of matrices with row operations, okay? So I'm going to start first with my coefficient matrix, right? 3, 2, 5, 3. And what I'm going to do now is I'm going to augment it, but instead of doing the identity matrix, I'm just going to put the numbers here, 8 and 14, okay? Now, a few things to highlight here. Your system needs to be set up the same way we talked about. X is lined up, Y is lined up, constants lined up, and equal signs separating the middle, okay? And essentially what the goal is going to be here with our matrix is if I can go ahead and get the identity matrix on the left, right, 1, 0, 0, 1, then on the right will be my solutions, okay? So that's what I'm kind of working towards, right? So we're going to do that here with this matrix. I'm going to do my row operations to make these, make the identity matrix on the left-hand side. So first, I'm going to go ahead and target my 0 right there. And we know to do that, I'm going to go ahead and do 5 times row 1 minus 3 times row 2. And I'm going to plug that in for row 2. All right, so we know how to do this already. I'll go ahead here, just switch colors so I can do my math. 3 times 5 is 15. 2 times 5 is 10. 8 times 5 is 40. And then on the second row, negative 3 times 5 is negative 15. Negative 3 times 3 is negative 9. And then negative 3 times 14 is negative 42. All right. Now, we know here that my first row is going to remain the same, right? So here, my first row is not being changed at all. So it'll just be 3, 2, 8. And now my second row, I'm going to add the numbers in red in order to get those. So 15 plus negative 15, 0. 10 plus negative 9, 1. 40 plus negative 42, negative 2. So that worked out really nice. I got lucky there because this 1 was what I wanted to work on next, and it's already there for me. So that's just lucky, happy circumstance. If it had been something like a 7, I would have multiplied row 2 by 1/7, just as we have previously. Now I'm going to use that 1 to eliminate the 2 right above it, okay? So in order to do that, I'm going to take row 1 minus 2 times row 2 in for row 1. Okay, so I'll go ahead here and do my multiplication again. So here, negative 2 times row 2, negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times negative 2 is positive 4. And now I'll go ahead. Row 2 will not change, right? We've kind of already figured that out. 0, 1, negative 2. And if I'm being honest, at this point, because this row is already done, I already know what the value of y is going to be, right? I already know my ordered pair for my solution, it's going to be negative 2, right? But we'll go ahead and keep working here. Now I'll add the 3 plus 0, and I get 3. 2 plus negative 2, I get 0. And then 8 plus 4 is 12. That was what I was talking about before. I now need to go ahead and target the 3 right here and turn that into a 1. Again, we know how to do that. It's just simply going to be 1/3 of row 1 in for row 1. All right, so that'll be my last step. Again, row 2 unchanged because I'm already done with it. 0, 1, -2, which is my y value. And now here, 1/3 of 3 is 1, 1/3 of 0 is 0, and 1/3 of 12 is 4. Now this is my x value. So my solution here, right, is essentially set up where I've got the identity matrix on the left, and on the right I have x, y, my solution. So my ordered pair will be 4, -2. And that's how we use row operations to solve a system of equations. Again, if I were to plug 4 in for x and -2 in for y back in the original problem, it would satisfy both equations. Okay, so we'll go ahead here and I'll ask you guys to go ahead and try a problem without me. So this problem is going to be the system of equations 2x minus y equals -7 and x plus 4y equals 11. All right, and I'll tell you the answer. The answer is going to be -1, 3, right? Because I'm not interested in the answer. We can find the answer any number of ways. What I want to know is, do you understand the row operations? So your actual solution will be the work, the steps that you take to get there, okay? The only thing you need to do for today's assignment is upload a copy of your notes with this problem that I just wrote done, okay? Or at least with an earnest attempt, okay? And then tomorrow we'll go ahead and practice this a little bit more in class. All right, guys, take care.